We are on lesson 20, question number 6. We're looking at Descartes' rule of signs to help us determine the number of possible positive real rational roots and the number of possible positive negative real rational roots. We've already figured out how to find all of the possible real rational roots. We did that by taking plus or minus the factors of the leading coefficient over the factors of the constant term, and we got all of the possible roots of that answer and then of that particular problem. And then what we started doing is testing roots with synthetic division. And the way we did that, we did synthetic division, and when we got a remainder of 0, we knew that it was a root. And then what was the bottom part of that synthetic division was what was left of the equation when you take that factor out, and it would be 1 degree less than the original. And then if it was a fourth or fifth power, we would have to go through that process on each step until we get it down to an x squared, which is a quadratic, and then use the quadratic formula. Well, what we can use Descartes' rule of signs for is determine how many of the possible roots are positive and how many of the possible roots are negative, so that when we begin the trial and error process with synthetic division, we'll decide to trial and error positives first rather than negatives first if there's more possible positives. Or we would decide to trial and error the negatives first rather than the positives first if we determine that there's more possible negatives. Okay, so here we go. So we want to know the number of possible positive and possible negative real zeros. And the way we're going to do that is to find the sign changes. Okay? And so when we look at the number of sign changes in these terms, we have 4 terms. And the first term is positive, and you can write this down. The second term is positive. The third term is positive. And the fourth term is positive. It went from positive to positive, positive to positive, and positive to positive. How many sign changes were there? There were 0 sign changes. If there are 0 sign changes, that tells us that there are 0 possible, with 2 S's in it, positive real zeros. So we looked at the sign changes. The rule is that if there are 0 sign changes, then there are 0 possible positive real zeros. If there's 1, then there's 1 or 1 minus 2, which would be negative, which does not exist. So you would take off 2 at a time. So it'd be that many, or that many minus 2, or that many minus 2, or that many minus 2. Example, if this was an x to the somethingth power, a huge power, and there were 5 sign changes, we would say that there's 5, or 5 minus 2, which is 3, or minus another 2, which is 1 possible positives. Now, why would we take them off in 2s? Because if they're not a possible positive or negative rational, what happens when we lose one? When we lose one because of a square root, we lose them in pairs because we lose it in its conjugate, right? And if we lost it because of an I, we would lose them in pairs. So when a real rational drops out, they drop out in pairs, okay? So the idea is it's going to be that number or that number minus 2, or even minus 2, and then when you can't take away 2, you can't do it. 0, you can't take 2 from, so there's just 0 possible real rational zeros. Now, to find the number of possible negatives, this is possible positives. To find the number of possible negatives, we actually do f negative x. We look at f negative x. Now, let's go through the work and show what it looks like. F negative x would be negative x. We would be replacing the x with negative x, you understand? Which would be negative x to the third plus 2 times negative x squared plus 5 times negative x plus 4. We would look at f negative x. Okay? Now, when you cube a negative, what do you get? A negative. When you square a negative, what do you get? A positive times a positive is a positive. Got to think some sign rule stuff here. When you multiply a positive times a negative, you get a negative. And so when we find f negative x, that's what we end up with. Negative 5x. The 5 dropped out. Thank you. And then we want to identify the signs. Okay? The first sign is negative. The second sign is positive. The third sign is negative. The fourth sign is positive. And then we will identify the number of sign changes. From negative to positive here would make one sign change. From positive to negative here would make the second sign change. From negative to positive here would make the third sign change. There are 3 sign changes. Because there are 3 sign changes, there are 3 or 2 less than that 1. Remember, they drop out in pairs. Possible negative real zeros. You understand that? You may think, well, what good does that do us? Well, instead of using trial and error with all the positive answer choices, we wouldn't even try any possible positives because there's not any. You could try those all day and use up 5 sheets of paper with synthetic division and you're not going to get a hit because we just determined with Descartes' rule of signs that there are 0 possible positive zeros. So when we start our trial and error with synthetic division, we're going to choose negatives because there's either 3 or 1 possible negative real zero, whereas there's no possible positive real zero. All right, so we have determined that in this polynomial function, there are 0 possible positive real zeros, and there's either 3 or 2 possible negative real zeros. So when we start that synthetic division thing, we would choose negative choices rather than positive choices to put in that little spot right there, right? Because we could try positives all day and we're not going to get a hit. We just figured out there's not any. Okay? Question? So I said 3 or 2 here, and it's 3 or 1. 3 or 2 less than 3, which is 1 possible negative real zeros. There we go. Boy, you got to think about that. Okay, any questions on number 6? Number 7. Number 7, to check for the number of possible positive real zeros, we're going to look at the signs that were in the original function and the signs are positive, negative, positive, negative. Once we've determined the signs, we can find the number of sign changes. Once we've determined the signs, we can then determine the number of sign changes. Now, it went from positive to negative between the first two terms, so there's one sign change. It went from negative back to positive, so there's two sign changes. It went from positive back to negative, so there's three sign changes. So there are three sign changes in the original function. Therefore, there are three, or two less than that, one, or two less than that, which is negative, so we don't use it, possible, positive, real zeros. We could say real rational zeros. Didn't have room. I'm just kidding. Okay. But so we determined the number of possible positive real rational zeros. Now, to find the number of possible negative ones, we need to find f negative x. And to do that, we replace the x in the original function with negative x. And so we get that f negative x is, now an odd number of negatives creates a negative times a positive is a negative 5x cubed. And an even number of negative creates a positive times a negative is a negative 3x squared. And a negative times a positive is a negative, and then I have a minus 1. Let's see how we got that. So the signs that we ended up with are negative, 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 negative. No sign change, no sign change, no sign change. There are no sign changes. Therefore, there are 0 possible negative real rational zeros. So on this particular problem, if we were going to do the synthetic division and we were going to make choices of all those possible zeros that we would have found using the rational root theorem, we would choose positives in this case rather than negatives. Okay? Any questions on that? In the next problem, we're going to put all this stuff together. Okay? All right. Is everybody good? So, question number 8. It says, find all the zeros of the polynomial function or solve the given polynomial equation. Use any or all of the skills above, and we'll just go ahead and use all of them just because we need to see it. So, the first thing we would do is try to find all possible. We want to find all possible rationals, right? How do we find all possible rational zeros? The leading coefficient is 1. The constant is 10. what do? Plus or minus all of the factors of the leading coefficient over the factors of the constant term. So we have plus or minus 1 over 1 or 2 or 5 or 10. Remember doing that? I did it, do it the other way. Wow. That's weird. I'm having a backwards day. We did plus or minus these, plus or minus the factors of the constant over the leading coefficient. And the reason we usually do that is that constant is usually bigger, so it creates less denominators and it's easier to deal with. Okay? Sorry about that. Thank you. And so we're going to have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, over the factors of the leading coefficient, which are 1. And if there was more than 1, we'd say 1 or whatever. Okay? Like I tried to do wrong there. Yes. I was going to enjoy all those fractions. No, it wasn't going to work right, was it? Okay. I was going to enjoy making fractions that were no good. So we're going to have 1, positive 1 over 1, positive 1. Negative 1 over 1, negative 1. Positive 2 over 2, positive 2. Negative 2 over, positive 2 over 1, positive 2. Negative 2 over 1, negative 2. Positive 5 over 1, positive 5. Negative 5 over 1, negative 5. Positive 10 over 1, positive 10. Negative 10 over 1, negative 10. If we were to line those up from least to greatest, we would have negative 10, negative 5, negative 2, negative 1, 1, 2, 5, 10. That's interesting. I put 2 negative 10s. Thank you. That was cool. And I need a negative 5. I wish I could back up and re-record, but that's okay. Negative 10. I'm glad you are paying attention. Negative 10, negative 5, negative 2, negative 1, positive 1, positive 2, positive 5, positive 10. These are all possible rational zeros. Okay? All possible real rational zeros. Now, we could just start doing synthetic division right here, or we could apply the Descartes' rule of signs to try to figure out, would it be better to choose the possible positive ones or the possible negative ones? Well, let's go ahead and use Descartes' rule of signs. If we do that, then we would come up here and we would look at the number of sign changes. We have a positive, we have a negative, we have a negative, we have a positive. There's one sign change between the first set. There was not a sign change there, and then there's a second sign change. So there's 2 sign changes. There's 2 sign changes, and so that tells us that there is 2 or 2 less than that 0 real, possible real rational roots. Possible positive, real rational roots are zeros, okay? If we want to know the possible negatives, then we would have to find f negative x. And we would have negative x cubed minus 4 times negative x squared minus 7 times negative x plus 10. And so f negative x would be negative x cubed 4x squared plus 7x plus 10. The signs of f negative x are negative, negative, positive, positive. We have no sign change. A sign change here, there's 1. No sign change there. We have 1 sign change in f negative x. That means that we have 1 possible negative real zero or real root. Okay? So there's 2 possible positive real roots or 1 possible negative real root. So we've got twice the odds of choosing a positive than a negative, so we'll start with positives. So we're going to begin our synthetic division with positives. Now, what I'm going to do is clean house here just a little bit. And I'm going to write all my possibles up there again, just so we'll have it. Negative 10, negative 5, negative 2, negative 1, positive 1, positive 2, positive 5, positive 10. I know that there's 2 possible positive, and I know that there are 1 possible negative, and because of that, I'm going to begin my trial and error with possible positives. Somebody good with me so far? Okay. So to do our synthetic division, we're going to take the coefficients, 1, negative 4, negative 7, and 10. There's twice the odds of getting a hit on a positive than a negative, so we're going to start testing these positives. So we'll start with 1. In synthetic division, we bring down, so we bring down that 1, if you recall. And then we're going to multiply 1 times 1 and pop it up there. And then we're going to add and get negative 3. And then multiply and get negative 3. And then add and get negative 10. And then multiply and get negative 10. And then add and get 0. So we got to hit the first time with a positive 1. What does that mean things are going to look like now? What does this part turn into? It was x cubed. It's going to go down in degree 1. So this is a 1 what? X squared minus 3x minus 10. And this is, it's x minus the 0 of 1, which creates a factor of x minus 1. Very good. So the factor is x minus the root, correct? Now, what can we do now? We've got a quadratic, and so we want to factor that. Now, we can think, since a is 1, we can just stick an x there, right? And we can think, what can I multiply to get negative 10 and add to get negative 3? And the answer would be negative 5 and positive 2. And they go right straight in there. You remember that when a is 1? What can I multiply to get negative 10 and add to get negative 3? You don't have to use the whole AC method. Okay? And then what would you do? Set each factor equal to 0 and solve, right? So we know that this would produce that x equal 1 that we already had. And this would produce an x equal 5. And this would produce an x equal negative 2. So those are the roots of the cubic. Any questions on that? You could say x plus 2 equals 0, minus 2, minus 2. We got that. Any questions on number 8? Okay. All right, number 9. This is a 4th power. We need all the space we can get. I'll white this out at the bottom. Okay, so we are going to begin by finding all of the possible rational roots. And to do that, we will take the factors of the constant. They are 1, 8, 2, 4. We'll do plus or minus all of those over the factors of the leading coefficient, and the only factor is 1. So we're going to do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, over 1. Had that been 2x to the 4th, it would have been over 1 or 2. If that had been a 4, it would have been over 1 or 2 or 4, and it would have got pretty crazy. So we're going to have, in this first set, positive 1 over 1, negative 1 over 1. Positive 1 over 1 is 1. Negative 1 over 1 is negative 1. Positive 2 over 1 is 2. Negative 2 over 1 is negative 2. Positive 4 over 1 is 4. Negative 4 over 1 is 4. Negative 4. Positive 8 over 1 is positive 8. Negative 8 over 1 is negative 8. And then least to greatest, negative 8, negative 4, negative 2, negative 1, positive 1, positive 2, positive 4, positive 8. So we found all possible real rational zeros. We're going to go ahead and use Descartes' rule of signs to determine should we start with the negative choices or the positive choices. Using Descartes' rule of signs, then, in the original, we had a positive, a negative, a positive, a positive, a positive. Between the first and second terms, it went from positive to negative. It went from negative back to positive. There's 2 sign changes. It stayed positive the rest of the time, and so we have 2 sign changes. There are 2 sign changes, therefore there are 2 or 2 less than that 0 possible positive real zeros or roots. Just to save some space, let's just do this in our head this time. f negative x would be, this is an even number of negatives, so that would turn into a positive x to the fourth. There would be an odd number of negatives, which is negative, times the negative is a positive 2x to the third. There's an even number of negatives, which would be a positive x squared. There would be an odd number of negative, which is negative, times a positive, which is a negative 12x, and then a plus 8. So we can probably work that out in our head. If not, just write it all down and work it out. The signs are positive, 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 negative, positive. No sign change, no sign change, one sign change, back to positive, two sign changes. That means that there are two or two less than that zero possible negative real rational zeros. Well, there's the same number of choices of each. That was almost a waste of time. We still have just the same odds as one as the other, so we're just going to start choosing at random, okay? Didn't really help us that much because it's the same result for both. But we got good experience playing with it. All right, so it's trial and error synthetic division time. The original leading coefficient was 1, and then a negative 2, and then an understood 1, and then a 12, and then a 8. What do you want to start with? 1. Thank you. So we're going to bring down the 1, multiply. 1 times 1 is 1. Add negative 1. Multiply negative 1. Add 0. Multiply 0. Add 12. Multiply 12. Add 20. No good. We need a 0. So that was not a hit, but it's a what? It's a point. When x is 1, we know that y is 20 because the remainder in synthetic division is the function value at that x, right? So we got a point, but we didn't get a root. So we got to try something else. So we'll start over here. And we need to put something else there, and this time we'll try a negative 2. Because somebody said so. All right. So we're going to bring down the 1, multiply and get a negative 2, add and get a negative 4, multiply and get a positive 8, add and get a 9, multiply and get a negative 18, add and get a 6, multiply and get a negative 12, add and get a negative 4. We didn't get a 0, so we didn't get a root, but we did get a point. When x is negative 2, y is negative 4. So we'll try again. Do what? So we'll try negative 8. So we bring down 1, multiply negative 8, add negative 10, multiply 80, add 81, multiply, it's getting totally out of hand. So we're like, this is not going to work. We'll just stop in the middle. But that's good to try that because you're like, that's getting way too far out of whack too quick. We'll bail out of that. Let's go over to the positive end. That wasn't looking too good. Move over to a positive 4, somebody said. 1, 2, skip a few, 4. So we're going to bring down a 1, multiply 4, add negative 2, multiply negative 8, add negative 7, multiply negative 28, add negative 16, multiply, and it got way out of hand again. So that didn't work. But we could have found another point, right? And so somebody said, well, let's try negative 1. We've tried the negative 8, and we tried the positive 4. We tried a positive 1 and a negative 2. So it's been suggested that we try the negative 1. Now we're trying this one. And so we bring down 1. We multiply 1. We add negative 3. We multiply positive 3. We add positive 4. We multiply negative 4. We add positive 8. We multiply negative 8. We add and get a 0, and we got a hit. Yay. Now, this is an x to the 4th power. So this is only going to take us down to x to the 3rd power. Then we'll have to do it again. But we've already marked some possibilities out, which is going to help us. We're not going to try those again because they didn't work the first time, right? So, right now we have, if you have a root of minus 1, then what's the factor? Plus 1. And we were at x to the 4th, right? So this is an x to the 3rd minus 3x squared plus 4x plus 8. Now, the question is, do we have to do all of that? What are the possible factors and possible positives and negatives again? No, this is the same problem we started with, right? It has the same possible positives, the same possible negatives, the same possible roots. So we need to take the coefficients here, and we need to do synthetic division. So we're going to take the 1, the negative 3, the 4, and the 8. I'll do it up here. The 1, the negative 3, the 4, and the 8. And we're going to do synthetic division on that. And we already threw away the negative 8 and the negative 2 and the negative 1 and the positive 1 and the positive 4. But which one was a hit? Negative 1. Could it be a hit twice? That's a possibility, is it not? That we could have the same root. So we might want to try that one again. But we're only going to try negative 1, positive 2, negative 4, positive 8. Because the others already get kicked out, okay? We'll just pick up there next time. We'll just pick up right where we left off. I'll recreate that, and we'll continue the video right there. Appreciate your attention.